Well, welcome to the DZS webinar on fiber extension MDU solutions. My name is Jeff Burke. I'm going to be the moderator for this session today, and we're very excited to have you join us here today. Topic-wise, we're here to talk about fiber extension for MDU solutions. And for those of you who have been deploying fiber for years, I think you all know that MDUs are difficult for a number of reasons, both from getting access to the infrastructure that you ultimately need to get access to bring gigabit solutions into these environments, and it can either cause challenges both either from an access perspective or from a cost perspective. And yet, given the fact that we all have MDUs in our serving areas, we have to solve this problem one way or another. I think one of the most interesting things about MDUs is that not only are they essential, we all have them in our networks, but in many circumstances they are required to be deployed as well. So if you're going to solve the fiber to the home business case for your own company, you're going to have to meet this challenge head on. I'm extremely excited to share with you that with the acquisition of Netcom this last month, DZS has actually been able to bring into its portfolio what we believe is the world's best fiber extension solutions for delivering gigabit services over multiple optional or existing infrastructures. So with that said, what I'd like to do is also mention that as we pull this portfolio in, we also gained some real world preeminent expertise in this subject as well, not only from a development standpoint, but also from a deployment standpoint with our customers who have been out and been actually deploying this out in the field. So with that said, let's go ahead and look at the agenda on the next slide. We're going to spend the next 30 minutes or so really talking through the Kenneth, can you go to the next slide, please?
If my internet
it got stuck there for a second. We're going to address what the big deal is with MDUs, what fiber extension is, and how does it help overall, making MDUs easy just from a deployment standpoint, as well as just a quick introduction to the DZS fiber extension portfolio. And then we're going to kick over to TDS, which is going to share from an operator's perspective what the realities are as to deploying this technology and what they've been able to achieve with it. At the very end, we'll do a Q&A. I wanted to let everyone know just logistically that our intent today is to get through this the next 30 or 40 minutes or so. We're also going to utilize the Q&A module to answer any questions at the end. So as we go through today's presentation, if you have any questions that you want to have us address, please go into the Q&A module, log that. I'll be monitoring that throughout, and we'll have our guest speakers address that head on as we get to the end of this presentation. So with that said, let's go and take a look at who we have talking today. So as I said, my name is Jeff Burke. I'm the moderator of the presentation overall. Joining DZS this last month is Kenneth Green, the Director of Product Management for our Connected Edge, right? So we're extremely excited to have Kenneth join us and be able to lead this discussion today from a technology perspective. And at least as exciting, we have one of our customers, Jared Hessling from TDS. He's a senior manager of product development there, and he's going to be walking through how TDS has both selected and had experience with deploying this technology. So welcome, gentlemen. Really excited to have you join us here today. And with that, I wanted to go ahead and pass over to you, Kenneth, where you can start to walk through what the big challenge is here that we have with MDUs.
Thanks very much, Jeff. Hello, everybody, and welcome to tomorrow. I'm calling in from Australia, and it's already Friday. So if any of you want to win the football, well, you can just send us a message. Not giving out any lottery numbers, though. So, what's the big deal with MDUs? Why are we here to talk about it? There are a lot of them. In Europe, there's about 96 million dwellings in MDUs that have less than 10 premises. The US has over 65 million dwellings in MDUs of around 3 premises or more. And, getting fibre from the street to the end user is the biggest challenge of fibre to the home deployment. And MDUs can make that especially difficult. So the carrier's challenge is to find the fastest and most cost-effective way to transition MDUs over to PON services so that the operators can capture or retain those customers and generate revenue sooner and increase return on investment from the fibre deployment. You know, there's a lot of money that has been invested and has been raised and financed to roll out fibre across the geography. And it's great to get, you know, numbers in terms of homes passed, but the real challenge is getting homes connected and converting those homes passed to homes connected and services that are generating revenue for the operator and return on investment for all the finance folk. So I don't think anyone disputes that fibre to the home is the best access technology out of the myriad of choices. And it's the current focus and the target future for just about every wireline operator around the world. But deploying it can be costly, it can be hard to resource. There's complex issues around the labour force and training up people and a competition for that labour force. MDUs can be particularly difficult. They can often impose restrictions on where you can run cables in the building, and they often require custom design work on a case-by-case basis. The other problem is that scheduling to get into end user premises to terminate that fibre in the home can be difficult. You often have to negotiate with the building owners, sometimes with individual end users. You can have a lot of trouble getting cooperation, and there are multiple stakeholders involved. The other problem that a lot of operators face is that even when they get through all of that negotiation and they set up appointments, about half the time those appointments fail, either because the deployment force are overcommitted and they don't make it in time, or because the end user said they would be there, but they're not there. And so you've got to roll the truck again. So all of these things make MDUs particularly challenging. So fibre extension, it's a term that's sort of come into use over the last couple of years. Previously, we used to talk about fibre to the distribution point, but that was a bit clumsy. And really, it didn't communicate what the real value is here, which is that we are finding a way to deliver that fibre grade service, extending the fibre all the way to the end user, even when there are challenges about physically getting the fibre there. So if we look at fibre to the home, some of the challenges that we face with deploying our networks, particularly civil works, you have to dig trenches or tunnel underneath pathways or tear up people's front yards. And that's expensive, it's time consuming, and it's unpopular. Often it takes multiple truck rolls to complete a professional installation. There's one team who are, you know, doing the physical civil works, another team comes along and deploys the fibre to the home, another team comes along that has to then terminate that fibre into the home and potentially, you know, install an ONU. It involves lots of appointments that are complicated to manage and add to the cost and delay. They often have this negotiation challenge with multiple entities. And it's also hard that a lot of operators find that it's just too hard and they skip the MDUs and they just move on. They run the fibre down the street, they connect the ones that they can that are easy, and they skip the MDUs and decide they'll come back to them later when they have the time, or they can find a solution that makes it cost effective. And those stranded MDUs, they can have a big impact on the brand perception of the operator. People get very grumpy when they see the neighbour on their left has a service and the neighbour on their right has a service and they can't get a service. And so, you know, operators don't like leaving those stranded customers. And, you know, I've seen examples with, you know, major tier one operators in the US, for example, where there are whole suburbs that have been sort of stranded with ADSL for years and years because of the challenges of having to do civil works and the restrictions in not being allowed to run aerial fibre in those in those suburbs.
And the thing that I've noticed is that they, in those circumstances, fair or not, they blame the operator, not the other entities that might be involved in creating those challenges for deployment as well.
Absolutely. You know, they don't blame the community organization that passed the rules that says we don't like wires, you know, hanging up in the air. They blame the operator because they're not getting the service and they're very unhappy about it. So with fibre extension, we help to solve those problems. There's zero civil works. There's very simple physical installation. There's no need for local AC power connection, which is a huge issue. I'll talk a bit more about it in a moment. Very simple connection into the home because they're using existing infrastructure. MDUs become easy because, again, talk about the different options there are, but essentially you're using existing infrastructure at the very least within the building, sometimes even to access the building. You can serve from outside or inside from any suitable location that's nearby. And the deployment cost can be significantly lower than it is for fibre to the home. In fact, by definition, if the deployment cost was low enough, you would be connecting those customers with fibre. It's those customers where it's simply not cost effective, either because it takes too long or because there's too many overheads involved, where you're not going to connect them with fibre, maybe ever. So by definition for those customers, this is a cheaper solution and it's cost effective enough that capturing those customers and getting your ARPU from them is very worthwhile. And particularly with DZS Netcom DPUs, they can be provisioned using the standard processes that are already in place for provisioning services on your existing ONTs. And that makes a huge difference to the overheads involved in introducing the technology because there's a very low barrier from an IT perspective.
Okay, I see you mentioned a DPU there. What is a DPU?
Oh, thanks, Jeff. Yeah, DPU stands for a distribution point unit. So as I mentioned, we talk about fibre extension now, but a few years ago, the terminology was FTTDP, which is fibre to the distribution point. And the distribution point was defined as that point in the copper network where the distribution copper was split out into the individual lead-ins to end-user premises. And so that distribution point was where logically you would locate this piece of equipment, where you could bring the fibre to the distribution point, terminate it on the DPU, and then make use of those lead-ins into the premises. So yes, you shouldn't assume that the jargon is known by everyone. So where do you put DPUs if you have them? The answer, at least with DZS DPUs, is anywhere you like. They can go inside, they can go outside, they can go on walls, on poles, in pits underground, in manholes, pedestals. They can hang from strands, and they can be distributed across the floors within a building. And that gives you, as the operator, a tremendous opportunity to optimize your deployment standards, minimize your costs, and maximize the speed of deployment. DZS DPUs support GPON and XGS-PON, and unique in the industry, have multi-vendor OLT support. So as Jeff mentioned, DZS recently acquired Netcom. DZS, of course, has its own outstanding family of OLTs, but Netcom previously was not associated with any single OLT, and all of the products are developed to support all of the major OLT vendors in the market. And as you'll see, we have deployments against them around the world. Excuse me. And you know, with this technology, we can deliver gigabit services out to about 150 meters or 500 feet of leading. Varies, of course, depending a little bit on the nature of the copper and the quality of the copper, but you know, that's a pretty good guideline.
I think it's a major distinction I want to make sure folks understand here very early on in this presentation, that One is that basically, no matter what infrastructure you have in place, right, from a vendor perspective, the DZS solutions here can be deployed and look like an ONT that's presented in that environment. So extraordinarily flexible. And of course, as you point out in this particular slide, really can be deployed just about anywhere, right? To not only against any vendor, but also in really the optimal point in the network for your particular need.
Exactly, Jeff. So here are just a few examples of how fiber extension can solve problems in different kind of geographical areas. If you look at the top left, it's really a typical street where there's a legacy, very copper infrastructure in the street, and there may be a pit or a pedestal, which is the distribution point, where those individual leadings are peeled off from the main distribution copper. And by locating a DPU at that point, you can intercept the copper, disconnect it from the legacy upstream copper, and make use of those buried leadings directly. No trenching, no digging, no drilling, no tearing up people's driveways and gardens. And a typical installation, once you've trained your deployment teams, is 45 minutes, maybe an hour, and you've connected 4 homes instead of waiting multiple weeks to arrange appointments. Maybe you have to wait several months to get the team with the drilling equipment because they're so heavily booked. You can connect customers the day or the day after they go on your web portal and sign up for a service, and you can have a technician out there and they can install it and have them connected in 45 minutes. That's quite a big difference. In the top right here, we see another scenario. This is one of the ones I was talking about that we saw in the US, where there was just an entire suburb where the copper was direct buried. There was overhead copper that then ran down the poles, was direct buried, going out to the homes, and the operator was allowed to run their aerial fiber along the poles, but they weren't allowed to do aerial drops to the homes. And so they'd run the fiber, and this whole suburb had fiber running through it. They didn't have a single home connect. With our solution, they were able to connect the entire suburb, in a matter of weeks. So it really transformed this area from being a tragic island of ADSL sufferers into delighted, gigabit customers. Then you have sort of a garden-style condos or community units. Similar thing. You can have a lot of problems with blocked conduits and the like. You can avoid all of that with the DPU. And the other interesting one is in regional or outer urban areas where you may have run fiber down the main road, but it's too expensive to run the fiber up those very long driveways. And so we have a solution for that as well. So there are a lot of different ways that this technology can solve the access problem and get you into those customer homes quicker, get them connected sooner, and generate revenue sooner. So just a little bit about the technology and how it looks in the context of a network. So the upper swim lane here that's called reference shows the standard architecture for a PON network. You have the central officer exchange shown here on the right-hand side where the OLT resides. You have your distribution fiber that goes out into the world. It then runs into a splitter which divides up that fiber into sort of last hop fiber. And then in a classic fiber to the home deployment, that last run fiber goes all the way into the home. It terminates on an ONT, which then provides an Ethernet handover to the residential gateway or the Wi-Fi access point. So that's the classic architecture. Our solution looks to the network exactly the same. It is an ONT It terminates the fiber and it provides an Ethernet handover to the end user's residential gateway. It just so happens that the very last hop, the very last, 500 feet or so, is done over the existing infrastructure, over the copper. And one of the neat things here is that the DPUs are reverse powered. That means they don't need connection to local AC power, which is another huge aspect of the flexibility. They get their power over the same copper connection that's used to deliver the broadband service. And that power is provided by the NTD in the home, which injects power back to the DPU and is a layer 2 bridge modem, providing the Ethernet port to the residential gateway. So essentially, the DPU and the NTD operate in your network just like an ONT. They look like an ONT, they can be registered like an ONT, configured like an ONT, and assured like an ONT, and maintained in terms of firmware updates. It all just looks like an ONT to your network and to your existing EMS. You don't have to install a new EMS. You don't have to create new complicated service automation software in your IT system that has to work across multiple systems. The same way that you deploy services today onto ONTs, you deployed it onto the DPU.
And Kenneth, just to be clear too, that can be either copper or coax in that environment, correct?
That's correct. It can be twisted pair or coax in that environment, and it can be any flavor of OLT. Not restricted to DZS, not by any means. And the other neat thing is that the NTD is automatically managed by the DPU. So you as the operator don't have to worry about the firmware that's on the NTD. That's all bundled together with the DPU firmware. And if it requires an update, the DPU will detect that and automatically update the NTD. So again, you just manage that DPU in your network like you would any other ONT. And when it's time for a firmware upgrade, you do it using the same tools, the same processes, and it takes care of the NTD on your behalf. So yes, our DPUs are ONTs, and they support all the standard ONT operational features: automatic discovery on the PON, automatic firmware upgrades from the OLT or via the OLT EMS, standard optical and thermal performance monitoring, the standard PON status and PM counters, performance monitoring counters, the standard UNI interface status and PM counters, and of course DianGuard. So the DPUs are reverse powered. So when the last user turns off their port or disconnects their service, then the ONT will lose power and it will send a dying gasp upon dying gasp, just like any other ONT. It's also important to understand that even though we have DPUs that have multiple ports, all of our DPUs will operate reverse powered from only a single port. So only a single user, the first user that gets service, they'll provide power through the NTD to the DPU and everything will work. As additional users configured up onto that same DPU, they will also provide power, and there's a fair sharing mechanism in the electronics which makes sure that the DPU draws power not just from that first user, but in a fair way from all users who are currently powered up. So we have multi-vendor interoperability, and we have operational commercial deployments across 3 continents against Nokia, Calix, Huawei, and Adtran. We have demonstrated in labs interoperability with DZS, EdgeCore, Gigabit, CTE, and we're very confident of supporting and maintaining that interoperability for all of our customers across whatever OLTs they have in their networks.
I also wanted to point out here, Kenneth, that it's only been a month, so really getting excited about having our first DZS operational deployment across this technology as well. So that'll be a big deal for us.
I'm looking forward to moving DZS from the green box to the blue box.
Kenneth, one other thing I wanted to make sure was clear to everyone that this is both GPON and XGS-PON as well across these vendors as well, correct?
That's correct. Yes. We support both GPON and XGS-PON across all these vendors. So just a little bit about reverse powering. One of the challenges, so I used to work for a network operator many years ago, and at the time we were deploying fiber to the home, but we were also deploying fiber to the node with VDSL technology, and that involved, putting cabinets out in the street and having to connect power. And connecting power to equipment in the street can be an enormous challenge. Power companies, sometimes some of us in the industry get frustrated because carriers can move slowly. They have a certain amount of inertia, and when they need to get things done, it can take time. But power companies, they are glacial, and you can wait 6 months, 9 months for the power company to provide you with a connection to a piece of equipment in the street. It can cost tens of thousands of dollars. And, even when you're putting a large piece of equipment like a DSLAM in a giant cabinet out there, that's still a significant cost. When you're putting a small, compact, high performance but relatively low cost piece of equipment like a DPU out in the street, you really can't afford to be paying that sort of money just to get it powered. And so all of our DPUs are reverse powered. They never need to be connected to AC power locally to their installed point. The NTD sits in the home, connects to an AC power point, just like any other piece of in-home electronics, and it provides reverse power to the DPUs. And it does that using in conformance with international standards. It's inherently safe. There's no safety risk in the home or to anyone that might be working on the network. And it frees you as the operator from all of these negotiations with power utilities, and it frees you with MDUs in particular. In many cases, there can be problems about getting access to a common power point in the building that isn't some private user's PowerPoint, that it's a part of the common power for the building utilities. Sometimes the building operator will insist that you have a separate power meter installed just to be able to connect your equipment. All of that's avoided. And then the icing on the cake is you actually never pay for power for this equipment at all, because it's drawing a few watts from the user, and you don't have to pay for that electricity. And users don't really care. They don't really notice. It's a very small amount of power. They're used to getting a piece of equipment that they plug in and connect to the wall to provide their broadband service. This is no different. And it's very rare that we ever get feedback from operators, that they get feedback from customers that they're worried about reverse powering equipment. And of course, generally the end users don't even know that's happening. So just to get an idea of the in-home network, so this is your typical in-home network. Little white box there in the middle is our NTD, connects to the power, it connects to the former telephone socket, and that's where the connection to the DPU resides. And it hands over with Gigabit Ethernet to the home gateway. And everything else in the home network is exactly the same as it was before. And if you as the carrier are providing that home gateway, you're free to upgrade it as Wi-Fi generations churn from 4 to 5 to 6 to 7 to 8. And the NTD just sits there and keeps doing its job, just like a layer 2 ONT. They stay in the network for years and years and years and years. There is a variant of our NTD which has a voice port on it. So just like some carriers provide triple play services, and then that means that they're providing a voice service via SIP over their ONT. The DPU and NTD combination is an ONT, and so we can do exactly the same thing here and provide SIP services directly off the NTD rather than going via the home gateway. It's really it depends very much. Each operator has a different strategy for voice services, whether they're over the top and in band with the user service, and therefore they come off the home gateway, or whether they're done this way. And our solution supports both architectures. The other benefit of this solution is that even for customers that just want a voice service, there are a lot of senior citizens who are not that fussed about broadband one way or another. They want to keep their copper service though. But there's a lot of aging copper infrastructure that operators would love to be able to decommission and stop maintaining and stop paying for, or even can't get spare parts for. This is a way using an NTD+V that you can move those legacy customers onto your PON network, still provide them with their voice service, port their phone number across, and now you're able to decommission that copper infrastructure. Little snapshot of the real world. These are real world speed tests, and you can see obviously on a gigabit Ethernet port, it's 1,000 megabits at layer 1, but with all of the overheads, when you run a speed test, around 940 to 950 megabits is the most you'll ever see in a speed test. And you can see that when you run a speed test on our solution, you get exactly the same as you would if you had the fiber coming all the way to an ONT in the home. You might have actually about 3 milliseconds extra latency over the ONT. So really, we think fiber extension and the way that we've implemented it and the features that we've got, it's a perfect solution for your PON network. It allows you to get the same performance as you would with fiber in terms of the gigabit service. You can use the network that you have today. You don't have to introduce any new complexity into your network. It's lower cost than running fiber, because if it wasn't, you'd be running fiber. And it's just so much quicker to deploy. So we can deliver gigabit services. You can rapidly connect SDUs, MDUs. You can recover disqualified ones that you may have already run the fiber down the street, but you've just bypassed those premises. You can reduce the operational costs. You never have to pay for power. The DPUs are OLT independent. So if you already have a dual vendor network, that's fine. If you have a single vendor network and you're introducing a second vendor, that's fine. And you can decommission legacy DSL and even voice POTS infrastructure while retaining customers and giving them a better service.
Hey, Kenneth, given where we stand with the timing for the hour, maybe can we jump over to Jarrett on slide 28 and have him talk about
just about yeah. So let's.
So at any rate, we are fortunate today to have a guest speaker from TDS who actually has had a couple of years worth of experience actually deploying these GFAST solutions. Jarrett Hessling. Jarrett, if you don't mind, I see you just came off mute. Maybe you can just introduce yourself really quickly and walk through through your slides.
Absolutely, Jeff, and thanks, Jeff. Thanks, Kenneth. Good morning, folks. My name is Jarrett Hessling. I lead the product development team here at TDS Telecom. So yeah, Jeff reached out and asked me just to say a few words, and I presented a few slides here. I'm going to walk through those. I'm certainly open to questions. As Jeff mentioned, TDS has we have been deploying the fiber extension product for a few years now, so we have some experience, but we're continuing to kind of evolve, right? So I guess, Ken, if you want to advance the slide. First of all, a little bit about TDS Telecom. We're a subsidiary of Telephone Data Systems, which is a publicly traded company. So all this information is publicly available. We're located in Madison, Wisconsin. That's where I'm at now. We are a bit of kind of I describe the company as a bit of a Frankenstein operator, right? So we've got wireline, we've got a significant amount of cable operations, and so we And, we operate in that realm as well as fiber. Fiber is obviously our most recent growth path. And so we're kind of well-rounded with regards to all those various technologies and have experience in operating those kind of deployments. And then you can kind of see our size there. So we're currently at about 1.2 million connections. Advance the slide, please. So first of all, I just wanted to put the slide up here to showcase that, look, GFAS has been around for a while. This isn't necessarily a new technology. It's been around for almost a decade, since the 2015 timeframe. TDS has been keeping an eye on the technology and reevaluating it as it has evolved. The first generation of GFAST used 106 megahertz of spectrum and was able to achieve about a gig total for speed, which is great. Was not gig symmetric. The technology was a bit immature. It was difficult to manage at that time. So, but over the years, it has evolved and many improvements have come along. And in 2018, the third generation, that A3, GFAS A3 was introduced, and that introduction doubled the usable spectrum from 106 megahertz to 212 megahertz. And the capabilities increased to allow for 1 gig symmetric speeds. And even more important, the technology became much easier to manage and deploy. So that is what TDS has chosen to deploy today, is that A3. Go ahead and advance the slide, Ken. All right, so what problem are we trying to solve here? For TDS, we had a large focus on MDUs, and Ken kind of spoke to this a little bit earlier. We wanted to be the provider of choice for those customers, but there are a ton of challenges enabling MDUs with fiber, right? So first of all, for new construction, we absolutely choose to lead with fiber. So if the builder will let us in, we opt to fiber up the building. But for brownfield and existing buildings, pulling fiber through that building is difficult. It's expensive. You often need access to each unit, which is disruptive to the tenants. And oftentimes, because of the scheduling, will take months, right? You got to get a contractor in there. You have to make appointments with each one of those tenants. It's difficult. There's quite a bit of challenges there. Next slide, Ken. So we view GFAST as an ideal solution to a lot of these challenges. Our approach is to bring fiber to the building and install the DPU. You can either install it in a common area in the building, oftentimes in the basement or a communication closet, or we are also installing the DPUs outside of the building. These things are, they're weather protected, basically. They're hardened, right? So the application is that you can install those on the side of the building or in the elements. And so we do that in many cases. We are then able to use the existing wiring of the building to each unit, which means that we're no longer pulling fiber throughout that property. And although there's additional costs, right? So you've got the additional cost of the equipment, the DPU and the NTD, you no longer need that ONT on a per unit basis. And our calculations, when we ran our various different models, found deploying this fiber extension products to be roughly 45% less costly on a per unit basis. So that's extremely attractive. Additional benefits is that disruption to the tenants is greatly reduced. You still need to get into the access to install the NTD, but installation is often simple enough. It can warrant a self-install. Now, we're not doing self-installs today, but that is something that we're considering and is on our roadmap. So I think it's absolutely kind of the solution warrants itself to a self-install deployment.
And Jared, if I may, there are operators who do self-install. Yep. They install the DPUs and then they mail the NTD to the end user, and they take it out of the box, plug it in, and away they go.
That's right. Yeah. And because you no longer need wiring contractors, you don't have to schedule with those contractors. We found that scheduling takes days rather than months, right? So we can leverage our field service folks to go in there, and they can, when they're get familiar with the DPU and the product, they're able to install the DPU and the NTDs, and you no longer have to pull that fiber throughout the building. So we found that it greatly decreases time to install and getting that product in the customer's hands. So another huge benefit for us. All right, next slide. So this slide is a little bit tongue in cheek, but we just really wanted to kind of illustrate how the technology performs. Our testing and experience has shown that, quite frankly, it performs very well. In fact, it matches all of the key metrics of gigabit broadband fiber. We had the fiber extension product in our labs, and we're doing all kinds of testing with regards to latency, throughput, jitter. And our findings is that it's extremely comparable from a with fiber, and from an end user perspective, the difference is almost completely transparent. So, again, it's performed very, very well for us. We're deploying it, and we're deploying fiber-like products over this technology. So, here's a couple of the next two slides are just a few performance graphs, and so. Our engineering folks have done some calculations and some testing on this, and this is a rate reach chart comparing the GFAST technology with DSL. And this is all over copper twisted pair, 24 gauge. So for copper twisted pair applications, obviously DSL is the preferred technology over long distances. When you get out up over 1,500 feet up to that 2,000 foot range. Or even 3,000 foot, you're going to want to deploy DSL. But for anything sort of in that under 2,000 foot range, we feel that GFAST is, performs very well. We're using with regards to this graph, we're using the GFAST 212 megahertz non-bonded application, which is that solid green line. And we're able to get, 100 megabit symmetric speeds at roughly 2,000 feet. So that opens up all kinds of additional use cases beyond MDUs, as I'll describe it, or as I'll discuss in some future slides here. So, all right, next slide. So as I mentioned earlier, TDS has a mixture of ILEC and cable properties. So there's a decent amount of cable plant out there that we manage. And we have been very interested in how this technology performs over coax shielded cable. And as you can see here, the distances you can reach with those fast gigabit symmetric speeds are very much extended. So this dark blue line up top, this is the Gen 3 212 GFAST deployment. The application over coax is tremendous, right? So we're able to get gigabyte symmetric speeds almost up to 1,000 feet, which again, just enhances and adds additional use cases. In order to use those GFAST over coax applications, you do need a bailin to convert the twisted pair to coax. And so we're testing that. We have not yet deployed those, but we're hoping for that future developments will bring some integrated bailins into the product set, right? So we feel that as a natural fit, to integrate those bailins into the DPUs and NTDs. I don't think that's something that's available today, but certainly something that we're looking for. So, all right. So, as I mentioned, TDS has been watching this space for years, and we've evaluated a number of vendor solutions. We chose Netcom/Casa solution a number of years ago, and that's really, I wanted to list out, here are the key differentiation reasons and the key reasons why we selected this solution. So first of all, they just made it easy to manage. Their implementation meant that we could simply use the same OMCI interface that we use to manage all of our ONTs to manage these DPUs. The DPUs essentially mimic an ONT, and Kenneth kind of illustrated this on some of the earlier slides, right? So you deploy these into your network, and there's some templates you will need to develop for your to use it over the OMCI management interface. But then at that point, it looks just like an ONT. And so it's extremely simplifies the solution. And it makes it such that you no longer need to deploy a software-defined network for management, right? So this was important to TDS because we didn't want a whole nother system to have to manage these these units and these DPUs. We wanted to keep it simple, so simplicity was key here. Next, it meets and exceeds the broadband form TR recommendations for reverse power. So these DPUs are extremely low power devices, and they're fed, they're powered via reverse power, meaning that the DPUs are powered from the end units, the NTDs. And what that means is, the installations are extremely flexible. You can install these almost anywhere, on the side of a building or in the basement or wherever. You don't necessarily need access to power because they're powered from those NTDs. So that was another kind of important aspect to our selection criterion moving forward. TDS is a triple play provider. So we have a voice, video, and data solution, and being able to support voice was extremely important to us. And the Netcom solution was one of the few that had SIP voice ports on the NTDs, which was absolutely needed for us, and we're deploying quite a bit of voice over the fiber extension product. So that was another criteria there. Of course, the Generation 3 A3 chipsets, leveraging the full 212 megahertz was important for us to be able to get to those gigabit symmetric speeds. And then the coax bail-in option, like as mentioned earlier, we have quite a bit of cable plant out there, and we're able to leverage the solution over that cable plant. And also in the MDUs, many MDUs, you can leverage the coax throughout the building and not just in the ground. So we feel that the coax bail-in option provides quite a bit of additional flexibility and power to this solution. And then, of course, the pricing, the cost reductions, the saves. I think I mentioned 45% earlier, roughly 45 to 50% over a fiber to the home fiber replacement in indoor.
Do you know what SIP stack you all are using?
I don't.
Is it MGCP, or I guess, Kenneth, maybe you can speak to what SIP stacks we support?
Well, we do support MGCP. But the configuration, basically we support the configuration that's a standard G.988 configuration, OMCI based configuration of SIP services. And we have different operators. SIP is a standard, and like all standards, it can be interpreted lots of ways. So voice can be a bit tricky, but we interop with a number of different soft switches and with multiple OLT implementations.
It was a question that was coming through on the Q&A, so I want to make sure that we addressed it since it was right in front of us.
Yeah, I can certainly follow up with anyone. I'll follow up with my engineering team and provide some details or some specifics there. So.
Gotcha.
All right, Kenneth, do you want to advance the slide? And so just the last slide here is, as we think about use cases beyond MDUs, right? So we've been deploying this technologies in MDUs for the last couple of years, and now we're starting to look beyond that. And we think that there's, first of all, a ton of application where we can leverage this technology. Many of TDS's markets are very rural in nature. And if you think about bringing fiber to rural areas, there's an opportunity to use the copper assets that you already own and leverage this fiber extension technology as either fiber drop replacement or even kind of that last 2,000 feet to provide 100 megabit symmetric or even 200 meg symmetric speeds, rather than obviously burying fiber in the ground or running it is very costly. And so we're viewing this as a cost savings measure with regards to replacing the fiber drops here. So we have not done this yet. We're evaluating it, but we feel that there's a lot of promise here in our LEC areas and even possibly our cable properties in the future, right? Being able to deliver those gig speeds and just leveraging coax in the ground.
I think it's a fantastic point that, I know we focused a lot on MDUs for this technology, but the reality is there are a lot of different applications for it. And I think TDS, may not be unique in this, but certainly, the leveraging of this to transition from cable into a fiber or mixed fiber fiber-like environment is actually a very strong, compelling case, I think, for a lot of operators, in particular in the U.S., I think.
Yep. Yeah, and with the government programs and being able to serve those customers with 100 meg symmetric speeds is extremely important, and we're trying to find the best, cost-effective way to do so at a good quality. So we think that this technology does that.
Yeah, absolutely. We have close to 1 million lines of non-MDU deployment.
Anyway, Jared, thank you very much for walking us through that. It's it's fantastic examples of how the technologies worked for you, and a great validation, I think, as to the unique approach that the solution really brought to the market, and really paying off in real life from a deployment perspective. With that, Kenneth, maybe you can kind of show everyone the overall portfolio so they get a sense of the variety of different units they can deploy in the market.
Yeah, thanks, Jeff, and thanks, Jared, very much. Appreciated your contribution. So we have a very comprehensive solution set for fiber extension. Covers GPON and XGS-PON. All of the products are outdoor rated. Most of the products are IP68, so they can be deployed underground or in locations that are subject to flooding. We have, as I mentioned, two versions of the NTD, one base version and version with voice. We have a range of balance to do coax connections, and we have a whole set of installation accessories that suit a wide variety of deployment scenarios, particularly outdoor scenarios, indoor scenarios, strand mounting. And we also have an installation tool, which is essentially a battery-powered power injector, so that when you are installing a DPU, you don't have to go into the end user's home to connect up an NTD and power it up just to register on the PON. You can power up the DPU on site wherever you happen to be installing it, get it registered on the PON, make sure everything is working, and then walk away and you know that it's a working system. I think we're ready for questions, Jeff.
Yes, well, I know that there have been a couple of questions that have come in through the Q&A, a couple we've addressed as we've gone through. But again, I wanted to emphasize for everybody who's on the webinar right now, if you do have a question, go to the Q&A module and enter it there, and we'll do our best to address it head on. So with that said, there's a question here that just was specifically with regard to connecting MDUs from nearby pedestals and cabinets. Maybe you can re-emphasize, Kenneth, just the ability to leverage. Well, first of all, they're hardened, right? And secondly, how you might do that in the network overall.
Absolutely, thanks, Jeff, and thanks for the question. Yeah, we have deployments in all of these different kind of scenarios. So you can be deployed in the basement inside the building. You can be deployed on the wall of the building, and you can certainly be deployed in a cabinet outside of the building. And we have deployments in all of these scenarios. If there's an existing distribution point where the distribution copper has been brought into a cabinet, and these can be very small, these pedestals, it depends whether you need to do a 4-port or even an 8-port in some scenarios. One of our customers in the US deployed 8 ports into these sort of street side dog houses, they call them. And you don't need power, you don't need anything, just enough room to get the DPU in there. In some cases, there's existing equipment. It can stay there as long as there's room, or it can be removed depending upon the operator's preference. And you simply intercept that copper on its way into the building, and you're good to go.
Great. So questions are rolling in here from a number of different perspectives. One is with regard to the future of GFAST technology in particular. I know that this solution supports XGS-PON as a feeder technology, but do we anticipate that there anything on the horizon for GFAST to go into multi-gigabit speeds?
Absolutely, Jeff. Yeah. So the standards bodies have developed the next generation of this technology known as MG-fast, or multi-gigabit fast. Fast is fiber access. Anyway, multi-gigabit. Yes. So that technology, it expands the spectrum from 212 megahertz to 424 megahertz, and then up to 848 megahertz. Broadcom have released their MG-fast chipset. Broadcom are the leading provider of chips to support G-fast technology and the only provider of MG-fast technology. And so, we're already prototyping with those chipsets. And with MG-fast, you have the capability to go above 1 gigabit. As many of the listeners would understand, the more spectrum you use, the attenuation with distance gets more aggressive. So the distance over which you can deliver multi-gig services will be quite restricted. But in an MDU, where you're typically less than 100 feet, perhaps, from cable run from the end user, then you're going to get a real benefit from MG-fast.
Okay. Quick question. You had mentioned this earlier, but there was a question on the latency that may be introduced by a solution like this. Can you just address that overall? Is there any extra latency that's introduced to the?
Yeah, there is extra latency compared to just having an ONT, because you're basically having that ONT function, plus you've got to transform the signals into G-fast and stream them over the copper. It's typically about 3 milliseconds incremental latency, which is insignificant in the vast majority of cases. Even gamers don't notice.
Speaks to what Jarrett was talking about as well, that it really is almost invisible to the end user what is actually feeding that home from a service delivery perspective. It just seems like it's just a lot easier to deploy than many other solutions, depending upon what scenario is being presented.
Absolutely, it is so seamless and an experience to the end user that some operators simply market it as a fiber service. They don't differentiate. They just say, "Oh, you want a fiber service? We can give you a fiber service." And sometimes they deliver it with fiber all the way to the home, and sometimes they use fiber extension, but to the end user, it's still a fiber service.
So 2 more quick questions before we tap out. One is, can you expand this to a 16-port option? Was one of the questions that was thrown out there. Thoughts on that?
Absolutely. So our portfolio has 1-port, 4-port, 8-port, and 16-port solutions.
And then the last was they're asking for operators from Africa utilizing this solution. I know that certainly GFAST as technology is being deployed in Africa. I'm not sure that we have specific examples of customers yet. Do you have any, Kenneth?
I'm currently working on a proof of concept with a customer in Africa, but we don't have any active deployments yet. But we're very excited to.
All right. Well, great. Well, I know that we are at the top of the hour. I want to make sure I take this opportunity to thank, in particular, you, Jarrett, for coming on and sharing your experience. It's invaluable for these sort of exercises to ensure that we get, the operator perspective. And you did a great job of walking us through that and the drivers. So really, thank you very much for coming on aboard and sharing your expertise today.
Yeah, thank you. I appreciate the opportunity.
And Kenneth, you definitely demonstrated that you are an expert in all things fiber extension. So really, thank you very much. I couldn't be more excited to have you as part of the team, as well as the overall additions of engineers and all that and experience that Netcom is bringing to the DZS family here. So really excited to have you both here. I want to emphasize for everybody who's on here today that we will be following up with you. We'll send you a PDF of the overall slides that were presented today as well. And you can always look and share this with your friends and colleagues. We'll put this up on our video site as well, so this can be watched after this particular time segment in case someone missed it. Okay. So with that said, any more information you need to get on this, you can always go to info@dzs.com or just go right on our dzsi.com, sorry, and go on the website, and we'll get right back to you and make sure that we can empower you with this fantastic technology. Okay. Again, hope to see all of you soon, and thank you for attending our session today.